Hello and welcome. If you're watching this through sixth form college, then you might be looking to apply for studying A Level Geology next year. My name is Richard Campbell. I am the geology teacher at the college, and these videos are just bits and pieces to let you know a little bit about the sort of thing that you could be studying if you pick A Level Geology. If you're just watching through the YouTube channel, hopefully that you find these interesting and learn a little bit about the geology around Stoke-on-Trent and other bits and pieces that I've done for my students during lockdown. Okay, so I'm stood in Hume Quarry, just near Park Hall Country Park in Stoke-on-Trent, and behind me you can see some rather large beds of red sandstone. Now what we're going to do is have a closer look at those in another video, but just telling you a little bit about how they were formed now. Now, geology is an earth science, and what we're doing is looking at the rocks and using them to understand the processes that form the earth and the processes that make the earth look the way it does today. Now, you're probably familiar with pictures of deserts where you see lots of red sand grains, and that is exactly how these sandstone beds behind me were formed. They were once part of a large arid dry desert area when the UK was much closer to the equator. Now, this is a principle in geology called uniformitarianism, which essentially says the present is the key to the past. The processes that formed environments in the past are essentially the same today. So, as I said, behind me you can see some red desert sandstones, and sort of behind the trees over there is Stoke-on-Trent, which is famous for coal, pottery, Robbie Williams and Stanley Matthews, and that's pretty much it, to be honest. And those coal measures were formed approximately 300 million years ago. The rocks you see behind me approximately 240 million years ago. So where I'm stood now, we're looking at a break in deposition of about 60 million years. So when you're studying geology, you're looking at sort of really long time scales and really long, slow processes. So that's just a bit of an introduction to the area. I am going to have another sort of look at the rocks in closer detail and go to another couple of sites around Park Hall and explain a little bit more about the processes that form these rocks. Okay, so having a closer look at these rocks, we can see that they are quite red in colour, and if we have a closer look at the rocks, you see they're made of relatively small grains, and you might just be able to make out a little bit of layering in there. Now these are a type of rock called sedimentary rocks, made from sediments. So these were laid down, the grains of sand were transported over periods of time, and from what we can see of these rocks we can tell that they were formed in a desert environment, but it was interspersed by sort of large scale flash floods. Now at the time the UK was much closer to the equator, and tropical regions probably sort of looking about 10 to 20 degrees north of the equator. So it was much hotter, much drier, and these grains have been transported over great distances, and that means that they appear quite rounded. Now if you imagine desert sand grains, beach sand grains, quite often they're quite rounded, and that's due to processes called attrition and abrasion, which over time makes them get rounder and rounder and smaller. So that's just a little bit about sedimentary rocks for you. Okay, we've climbed up a little bit higher into the quarry now, and we've got some really nice bedded sandstones here. Now you can see the layers running horizontally, and we can actually see some sort of almost what look like diagonal layers. Now those are known as crossbedding, and they're really useful because they can tell us how and in what direction the grains were being transported at the time of deposition. And from the angle of these crossbeds, we can actually tell that the river that would have been carrying these sand grains was actually heading northwards, and that sort of ties in with the whole of the sort of continental makeup of Pangaea at the time, where we had sort of lots and lots of different rock types being eroded further down in the south area like France, and those sediments were being transported northwards and deposited in sort of vast desert areas where the UK is now. Now, because we're a bit higher up, we can see over there Stoke-on-Trent, particularly sort of Longton and Fenton area. And as I said, Stoke-on-Trent is quite famous for coal, but that coal was deposited 60 million years before the rocks that I'm stood on now. So it's really interesting to find out about sort of how these processes have occurred to have 300 million year old rocks over there and 240 million year old rocks over here. You need to find out what processes have actually caused that to happen, and that's the sort of thing that you'll be finding out about in A Level Geology. Okay, join me in Hume Quarry, also known as Play Canyon, part of Park Hall Country Park, a triple SI, Site of Special Scientific Interest, and also UK RIGS, UK Regionally Important Geological Site. Now, what we're here to look at is some of the beds, which you can see standing sort of a good 10-12 metres high behind me. Now, this used to be an old sand and gravel quarry, decommissioned in the 1970s, and it was allowed to be sort of taken back as a nature reserve. And as you can see, the rock outcrops behind me are quite spectacular, and they're also really good for interpreting the environment in which these rocks were deposited. Now, as you can see behind me, those beds are sort of red sandstones, which we've seen before, but you can see just sort of above the bush line there some beds with sort of much larger pebbles in there. Now, what that tells us, those larger pebbles, is that there must have been a much higher energy mode of transport, and what is thought is we're actually stood in what was a sort of dry, arid desert with a few meandering, braided streams running through the middle, but every so often there were sort of large-scale flash floods which would bring larger pebbles, lots of sand from much further south, and deposit them across the desert area. Now, what we'll do is we'll have a closer look at some of those conglomerate beds, they're called, and find out a little bit more about them. So these conglomerate beds are made up of a series of pebbles ranging from sort of half a centimetre up to some of the larger ones are probably 10-15 centimetres in size. What that tells us is that rather than the sort of low energy which is required to move small grains, is that there was much higher energy in order to transport these much larger clasts, they're called, when we're talking about a conglomerate bed like this. And what this is formed from is actually a flash flood which flowed through the middle of the sort of desert region that made up Stoke-on-Trent about 220 to 240 million years ago. So what you've got is dry, arid desert with a few meandering braided streams every so often. Heavy rainfall further south means that all these pebbles are eroded and then they're transported possibly hundreds of miles to where they've been deposited here when the energy of the river level drops. Now, from these pebbles, they're quite rounded, which gives us an indicator that they've been transported quite a long distance. And there's all sorts of different types of grains in there, showing that they've come from various different sources. Now, we've got large grains, small grains, medium grains, and what we interpret from that is the fact that everything was deposited quite quickly. So this is the flash flood flowing through the area, and then suddenly the energy levels drop and everything is deposited quite quickly, giving us this sort of random texture. And in geology, what we call that is a poorly sorted texture, which indicates that sort of everything is sort of quite mixed up and has been deposited quite quickly. Now if we move upwards a little bit, we can see that we're looking at a more sandstone type bed. There's a few pebbles in there which have obviously been ripped up and transported as well, but we can see that the energy levels are much lower as we've got much smaller grains. And what we can actually see in here is some diagonal beds that are sort of dipping in that direction. I don't know whether you'll be able to see on this scale, but these are actually the crossbedding that we talked about before. And because they're dipping that way, which is north, it can tell us that the river was flowing north at the time. So all in all, quite a fascinating outcrop and quite a lot to be learned from here. Okay, to sum up the geology we've been looking at in the last few videos, still in Hume Quarry, looking at the Triassic red sandstone beds in Park Hall Country Park. We've looked at how these are 60 million years younger than the Carboniferous coal measures that make up a lot of Stoke-on-Trent. We've looked a bit about the processes that has formed these red sandstone beds and conglomerates. And we've also mentioned sort of the engineering side of geology, obviously the resources that are required. Now, geology is often associated with oil and coal and gas and sort of dirty polluting fossil fuels like that, which obviously geologists are required for. But geology is much more than that. Geology is so important for understanding the environment around us, understanding the way the earth works, and understanding the processes that make up the rocks. Because without those rocks we don't have resources. This phone that I'm recording it on has rare earth metals in it, which are only found in a small number of locations worldwide, and geologists are involved in sort of sourcing, exploration and the mining and processing of those. Water that we drink is stored in aquifers. Geologists need to understand water transport through those aquifers so we can maintain our water resources sustainably.